Okay, in this video, we're going to talk about vertical tangent lines and what that means. One of the things I want to make sure we are thinking a lot about is the difference between the function, the original function, and the derivative, or the function that gives us the slope at each point. So the function here is f of x equals x to the 1/3, sometimes also written as the cube root of x. I changed it to x to the 1/3 so I could think about it using the power rule. Then I took the derivative using the power rule, so 1/3 x to the negative 2/3. Now, one of the things we need to remember is that when you have a negative exponent, that means that that actually lives in the denominator of the function. Okay, so this function, f of x equals the cube root of x, this function exists everywhere. So this is the blue curve here. And this always exists. There's never a problem. We can always find the value. It's continuous on the whole domain. But what happens here when we take the derivative, which is the slope, it's not this green line, it's just the slope of this green line. As we can see, the slope of this green line is positive and it's increasing until for a moment right here, it becomes no slope. So when x is exactly 0, which I can't seem to get it to be, it becomes that it has no slope. Now, when it has no slope, that doesn't mean that the function doesn't exist. All that that means is that the derivative does not exist. So right here, actually it disappeared because it could not calculate the slope anymore of that line. So what is happening? So what's happening is if I plug 0 into the derivative here, I'm going to get 1/3 times 0, which is undefined. So if you're asked for the derivative of this function, the derivative of this function does not exist when x is 0. So you could say the derivative exists everywhere except x equaling 0. So it's not that the function doesn't exist there, it's only that the derivative does not exist there.